A meteorite is space debris which has survived impact with another body, such as Earth. Meteorites are often confused with meteors, which are the streaks we see in the sky as this space debris goes through our atmosphere. As this debris enters our atmosphere traveling at a high rate of speed, friction and pressure interact with the debris, causing it to heat up and radiate energy that we see as a meteor. These are often called falling or shooting stars. The sources of this space debris are asteroids, comets, and even the surfaces of other solar system worlds like the Moon and Mars. While in space, small grains to debris about a meter in diameter are called meteoroids. So if you find a suspicious looking rock, how can you tell if it's a meteorite or not? There are 4 visual clues to an initial determination. First, does the rock attract a magnet? It turns out that 99% of all meteorites contain some iron and they attract a magnet. Second, does the rock look burned? During the flight through the atmosphere, meteorites develop an almost charcoal-like exterior called a fusion crust. Third, does the rock look like it's been shaped as it came through the atmosphere? This is called aerodynamic shaping and is due to the debris' fast atmospheric flight. Fourth, does the rock have pits or look like someone put thumbprints into wet clay or Play-Doh? These thumbprints, called regmaglyphs, are also due to the debris' entry and flight through the atmosphere. Meteorites can sit on the surface of the Earth like many rocks. Weathering over time can change its appearance, raising the fusion crust, aerodynamic shaping, or regmaglyphs. So some of these visual clues might have been literally erased. Since 99% of meteorites contain iron, they will also contain the metal nickel. You can do a simple chemical test to see if nickel is found in the rock. No Earth rock contains iron and nickel together, so if nickel is found with the iron, it is a meteorite, not a meteorong. Meteorites are classified according to their makeup. The first group or class of meteorites are the stony meteorites. Most of these came from the mantle and crust of asteroids, from stony asteroids, or from other objects in the solar system such as the Moon, Mars, or even comets. If you look at the interior of a stony meteorite, you will see something quite different from Earth rocks. Stony meteorites are made up of silicated materials. You will also see metallic flakes. This is the iron and nickel. It turns out that 94% of all meteorites found on Earth are stony meteorites. The second class of meteorites are the iron meteorites. As the name sounds, they are made up primarily of iron with varying amounts of nickel. These meteorites are very dense, thus heavy when compared to similar sized stony meteorites. The interiors of iron meteorites are also quite interesting. One group of iron meteorites, called the octahedrites, exhibit a line pattern when etched with acid. Only octahedrite iron meteorites show this pattern, called the Widmanstätten pattern. The third class of meteorites is a mixture of the first 2 classes of meteorites, called the stony iron meteorites. On the exterior, these meteorites resemble the other 2 classes. But if you cut them, and again look at the interiors of one type of stony iron, they are quite spectacular. These stony iron pallasites are like cosmic art. A collision in space between an iron asteroid and a stony asteroid created these meteorites. You see the metal iron-nickel matrix surrounding the translucent greenish inclusions. This is olivine, sometimes called peridot. Other rare meteorites include those from the Moon and Mars. Something hit these worlds, ejecting bits and pieces out into space. Eventually, these space vagabonds ended up blasting through our atmosphere, surviving that entry and making it to the Earth's surface. So whether in space, blazing through the atmosphere, or ending up on Earth, this bizarre game of cosmic billiards has been going on for eons. And from these space visitors, we can learn a lot about our solar system.